In this lecture, we will do more about indexing data frames. In particular, we will try to index the rows. Last time we did a lot of columns, this time a lot of rows, and we will also do a little bit of plotting, but most plotting will be done in the next module. Here is a little list of Pandas tutorials that you can play with if you want more practice or more information. There is one on Kaggle. There's a little older notebook from Google, and there is a tutorial on DataCamp. The collab things I am using in these videos, they are linked from the slides. You can use them too. You can make a copy and play with it your own version. So in this lecture we will try to do the log and ilog, where log will be covering the rows by the index entries, ilog by integer index. We will look at group by, and we will do some basic visualization of data with matplotlib in a way that is integrated in Pandas. In the class we will use this data frame. So it has columns age, color, food, height, score, state, and it has row entries Jane, Nick, Aaron, Penelope, Dean, Christina, and Cornelia. The bold things are the names of the columns and the names of the rows, or you could say it's the index of the rows, right? So the name is the index. Often index is just a number. In our case, index is the name. Right, here is our workbook for today. First we'll do the import pandas SPD, and now we'll try to create a data frame. We have some data given as dictionary, where we have these are the names of columns, and here for each column we have the entry corresponding to the column, and we also have an index. So pd.data frame data. Now we created the data frame. You can see that the index is 0, 1, 2, 3, 4, 5, 6. We here have index that is more entertaining. It's names. So here we added the index as names. This will be the data frame that we will be using. I'll save the data frame in variable df, because this is how I will refer to it in the rest of this. Here is a main difference. Log will give you a bunch of rows, possibly columns, with particular labels from the index. So you look at the entries in the index, put it into log, and it will return the corresponding records. You can put there string, where if the string is what is in the index, and then you will get one entry. You can put there list, and then you get several entries. You can use the slice notations, and you can also use a big list of true and false that will say, I want these records and don't want those records. There is also ilog, which is similar to log, but instead of using entries from the index, it just uses integers 0, 1, 2, 3, 4, 5 to address the rows. Here is the first example with a row. Right, so we'll try to do a few things. One is that I will try to select only Penelope. If you do so, you will get a series that will correspond to the row. So you can see it's log and one entry you get a series. If you pass several entries as a list, you will get a smaller data frame. Right? We'll try to use lock and ilog. First we'll do lock. I will check if the data frame is loaded. So okay, data frame is still there. If you lock, and now you type Penelope, you will get series that is corresponding to one row that was indexed by Penelope. So it's a series, and it corresponds to one row. I'll look at again the df, so maybe I'll write here series corresponding to one row, right? And I can write here log. If I write here, what should I do? Cornelia, it's a series. If I put it here as a list, now I will have a data frame instead of series, and I can put more names of rows here, and then I will get a bigger data frame. Okay, so now it's data frame. You can always check it. Data frame. You can use a slice notation if you are selecting from the data frame using lock. Interestingly, you should see what happens with the last entry. Like normally, if you use the slice notation for integers, the first one is included and the last one is not. Here it's slightly different. Here it is the first one is included and last one is also included. So one has to be a little bit careful to not mess it up. Right? It's a little different than the normal experience. Right, now I will try to use the slicing notation. First I'll check that my data frame is still there. Data frame is still there. Right. Look. And now I will say I want from Aaron to Dean. Okay, so I expect to have these three rows. What is important to notice is that the Dean is included as well as Aaron. If you do this slicing notation, usually the last element is not included, but in this case it is included. Both Aaron and Dean are included, right? And then we try the notation where we select both rows and columns. So df dot block, and here I pick Jane, from Jane to Dean. Right, we have that. And then for columns, I will pick from color to height. Now we have a smaller data frame that contains only the rows and columns that we selected. And again, both color and height are included. Hey, ilog is using integers to describe the location. It starts with 0 and goes 0, 1, 2, 3, 4, up to the number of rows -1. you can put there integer that will give you one row. You can put there a list of integers that will give you a smaller data frame. And you can also use the slice notations. You may notice that in the iloc list you can use the negative numbers, and the negative numbers are telling you that you want to go from the end. Right? So -1 is the last entry, -2 is the second to last entry. So you can index rows from the end. Right? I'll try to use iloc this time. So we will do check if the data frame is there. Data frame is there. iloc, and you would like to select the fifth row. So index starts with 0, 0, 1, 2, 3, 4, 5. Right? 1, 2, 3, 4, 5. So it should be 4. iloc 4. Type. You get series. Okay. So this is selecting one row. iloc 1 to 5. 1, 2, 3, 4. Here you can notice that it behaves like you would expect, that it is the last one is not included. 1 is included, 5 is not included. Remember that this is different than when you do lock. We can do iloc, and here what are we supposed to do? Third and second to last row. Third is 0, 1, 2, so 2, and second to last, this is last, this is second to last. So now we have the second row and second to last row, and now we add columns 3 to 1, which is what? This is index 0, this is 1, 2, 3, so it will be height, foot, color, backwards. Height, foot, color. If you want to get rows and columns, what you can do is you first specify the rows, and then you write a comma, and you can specify which columns you want. And again, you can use slicing notation or list. And here we'll try to select both rows and columns with the list. So let's check that the data frame is there. Data frame is there. Now lock, and here square brackets. If I put here a list, maybe Jane, Penelope, and Aaron, I get a smaller table, Jane, Penelope, and Aaron. You can notice that I also permuted the rows such that the rows are in the same order. And then here we can make another list. First score, then age. Sorry, here's comma. So first score, then age, Jane, Penelope, and R. If you want to index different columns, if you want to have a bunch of columns, what you can do is use the indexing operator, the square brackets. If you have the square brackets and you put there one name of a column, you will get a series that corresponds to that column. And if you put a list there, then you will get a smaller data frame that has all the rows. There is a Another way how you can access one column, and here, for example, if you have the column food, you can have it in the operator and then put there the string food. You can also do df.food, and that will give you access to the same data. Right, we'll try to select the column food. First we check that our data frame is there, and then one can do it by square brackets and food. Alright, now we have the series that corresponds to type series that corresponds to one column. If you want, you can do it like this, df.food, and you get the same series. Okay? So some people like it. I prefer to write it like this because it's clear that you are indexing the column food and not calling some method food, but both work. Right, I'll try to select a list of true false. So let's first look at df, if I still have my data frame, and now I create a list to select, and I will have a bunch of true and false, and I need 1, 2, 3, 4, 5, 6, 7 of them. So maybe Jane is there. I don't want to select Nick. I want to select Aaron. I want to select Penelope. I don't want to select Dean. I don't want to select Christina. And I want to select Cornelia. So this is a list of true false, df to select. Up. And for each, this is now indexed by the row, and for each, this was for the first row, second row, third row, and whenever there was true, the row was kept, and when there was false, the row was skipped. This is a easy way how you can select bunch of rows. This is particularly useful if you have some more complicated way you want to filter your data. And what you can do is that for each row you calculate true or false if you want to select it or not, and then you leave it in one long list, and then you do this df and in square brackets to select, and life is great. You select the rows like all in one go. So this is a very useful thing. Group by is similar like we saw in Excel. You aggregate statistics for the rows that have the same value in some column. Here in example we can try to aggregate by state, and if you do group by, you will get similar thing that happens in Excel. Right, now we play a little bit with command group by. So I'll check if my data frame is still there. Alright, data frame, group by, and we need to collect, we want to collect records that are the same for some of the entries, and the only reasonable is state, because state here repeats the other don't seem to repeat, so group by state. Right, now it creates data frame group by object, and you can ask size. That for each of the states it says how many are there. You can also ask, for example, for sum, where for each state it sums up all the entries that are there. So here is sum of the 3 ages is 103, and if you sum the strings it concatenates them. So this is the sum. Go back to size. the most popular library for data visualization in Python is matplotlib. It's mainly for doing two-dimensional pictures. The pictures are typically very high quality, and you have a chance to customize them quite a bit. If you try to use it in the Google Colab, the pictures will appear inside the notebook that you work with, so it's very easy to work with and make some experiments. The matplotlib is a module that you have to import, library that you have to import. Typically what you do is import matplotlib.pyplot as PLT, and then you use the PLT to access the matplotlib. Pandas has its own entries how you can access matplotlib. You can use df, that's the data frame, .plot, and then you will be offered a bunch of different plots. So this is a way how you can get the matplotlib from Pandas directly. We will see more ways how to use matplotlib, not through Pandas directly, but in a more general way. Here we will try to use matplotlib in a way that is built in Pandas. If you don't have matplotlib, you need to install it, but we will expect it's installed on the Google Colab. Importing is import matplotlib.pyplot as PLT, and this helps to have the output of the matplotlib embedded in the workbook. Right, now it loaded. I will check if the data frame is still there. Data frame is still there, and if I want to make plots, df.plot, and here it shows some plots, so do bar plot, and it will, here it is, create a plot where for each row in the table it created an entry, and here are the three numerical things: age, height, and score. Okay? So we can use horizontal bars. Here it's again. Here I will cut the score first and then try to plot only the score. So here data frame, hop, and I want to see only the score. I have the series. You can do describe on it if you want. It tells us some numerical values, and if I have the series, I can do plot. Allows me to show the plots, hop, and here is the plot. Right, and now it's only the one data, only the score. But you can access it also differently. You can also access it by typing df.score.plot.bar. This will also work. Okay. It may also be the case that you want to first copy the little piece of df score, and now you can call df score dot plot depends, but maybe I should comment this one out first, because now, oh no, I need both, sorry, because here I copy the data and here I plot it. So it depends on what you need. Sometimes it's enough to copy just plot the data like this. Sometimes you may want to copy them first and then do the plotting. Here we try to continue with the group by and make a pie plot. So here is the data frame, And here is group. If I press tab, it will fill it. Group by. I will grouping by state. I will use size to count them. Okay, now I have one series, and what I can do is write here plot dot by hop. And here is the series that we had. You can see this was the 1, 1, 1, 1 and 3 parts. It's a demonstration how one can use the group by that will give you a series and plot it. So very simple and easy. You will try to explore the data frame using describe info, and we'll try to do some box plots. So if I have a data frame, still have the same data frame. If I dot describe, then it will calculate for the numerical ones. What is the count, mean, standard deviation, minimum, 25 percentile up to maximum. Right. If you write info, then it tells you what is in there. So something is considered integers, something is floating points, score is floating points, and some are just objects, which usually here strings. Right? Describe is a little mass and df.info. Here is types. Right. I will try to do box and whiskers plot. So if I do df.plot box, then what it does is it creates a box and whiskers plots for all numerical things that we have. I guess with the height it's easy to see. Right? This is the minimum, maximum, 25 percentile, mean, 75 percentile. And the score is not quite great because it's a little bit small. So what you can do is comment this out and right here df, select score, and now you do plot box. And now it's easier to see how the score is distributed among the participants. Right? So using the describe and info are your friends to see what are the data in the data frame, and then if you call the box, you will see some of the things from describe in a little bit easier to see way than just numbers. Here is a little quick refresher on some basic statistics. Let's say I have a data x1, x2 up to xn, and I would like to calculate few things. So first, mean. What is mean? Mean is the average, which means that I sum all these values, sum them all up, and divide by n. It can also be written x1 up to xn divided by n. Then there is variance. What is variance? You take the difference between x and the mean, and to make it always greater or equal than 0, we square it. You square this xi over me, and then you sum them up and they divide by n, which means you take the average difference from the mean squared. Right. So the disadvantage of variance is that if this x1 up to xn have some units, this variance now has the units squared. So one can take a square root of this to have the correct units. Okay? Right. So we'll try to calculate these for a little data frame, and we'll try to do it with the pandas, and we'll also try to do it ourselves. Right, so let's go. Here I import sqrt, square root, because I will need to compute the standard deviation. Right, so let's see. df.describe. I have a little data frame here. Let us count mean, std, min, max. Sorry. And I will try to print some of these myself. Print, a little more efficient. Alright. So let's try to save this. The number of entries can be done by len. So I can write print count len. Right, cool. Right, how to calculate mean? I need to sum all the entries. So I can say it's sum of all the data mean print it. I sum them up, and now I divide it by the number of the len data. Right, so far we are doing good, right? And now I need to calculate the variance. Variance was I sum xi without the mean, square those, divide by n. Alright, so how to do it? I have to go through all xi, so I'll do it. I'll make a list here. Xi minus mean, the whole thing squared. So remember, if I do the second power, I do the star 2 or xi in data. And now I have a list of these entries. Right? Hope you can see it. This is the list. Okay. What do I need to do? I need to sum the list up and divide by n. So sum. Now the list is summed up, 32, and I need to divide by len of data. Okay, so this is now variance. Okay, and oops. Well, was interesting if you noticed I was pressing these omegas. If you write Alt Z on or Option Z on the Mac keyboard, you get some funny characters. Oops. And now I pressed something too much. Anyway. And next thing what I would like to do is calculate the standard deviation. Right, so how do we calculate the standard deviation? It's a square root of the variance. So sqrt of the variance, and square root of variance is 2. This will be the std. And what you can notice is that pandas have different std than we calculated. And so why is that so? Well, I use different equation for calculating the variance. So what's the thing is that if you calculate the variance and standard deviation, you don't take the average. Instead of dividing by n, you divide by n minus 1. Right? This is little correction, because it's saying this variance and standard deviation is correct if you have all possible entries in the population. But sometimes you just take a sample and you would like to account for the little uncertainty in the sample, right? So this is a correction that's often applied, that one is subtracting here 1. So you are dividing by slightly smaller number, which means that the result is slightly bigger, right? So we can correct it here. If I do the variance and divide by length of data minus 1, then I get 213808, and if we look back, 21380, and here it's become rounded, right? So the point was make sure that you know what is actually being calculated.